Welcome everyone to the section 5, which is create your own artificial neural network. In this section, we are going to do the following. First, we will know what is deep learning. This is the advanced part of machine learning, which is inspired by our human brain, and we will know all the pros and cons about that. Then we will implement that knowledge in a real-world case study where we will use artificial neural network in a bank dataset of 10,000 customers. After that, we will encode our categorical features. Next, we will do train test split and feature scaling. In the next step, we will initialize our artificial neural network and add layers one by one. Then we will compile and fit the artificial neural network in our training set. And finally, we will make confusion matrix and validate our model performance. What is deep learning? In this video, we are going to do the following. First, we will know a bit history of deep learning. Then we will talk about the neurons. After that, we will know about activation functions. Next, we will know gradient descent and stochastic gradient descent. And finally, we will know about backpropagation. So without further ado, let's straight dive into it. Okay, this gentleman over here is Geoffrey Hinton. He is known as the godfather of deep learning. He did research on deep learning in 1980s and he published lots and lots of research papers in deep learning. Right now he works at Google. So the idea behind deep learning is to mimic how the human brain works or operates. So why we try to mimic that? Because human brain is the most powerful tool on the planet for learning or adapting skill and applying it. And if computers could copy that, then we can leverage the power of our brain through our machines. So let's see how this works. This is the actual section of our human brain, and this is cerebellum, which is this part of your brain at the back. It's responsible for keeping your balance, language capabilities, and decision making. So from the picture you can see there are billions and billions of neurons and all are connected with each others in your brain. So that's what we are trying to recreate. So how do we recreate this in a computer? Well, we create an artificial structure that is called artificial neural network where we have nodes or neurons. The input layer's neurons connected to the hidden layer neurons and hidden layer neurons connected to the output layer neurons. So this is pretty cool, but what is deep about? Where is the deep learning here? It's nothing deep here. Well, because then we take it to the next level, we separated it even further and we have not just one hidden layer, we have lots and lots of hidden layers. And then we connected everything just like our human brain. So now we are talking about deep learning. Now let's talk about the neurons first. This is a picture of a neuron. It has dendrites, which works like a receivers for that neuron, and it has axons with a long tail, and it works like a transmitters of that neuron. Here you can see an actual images from our human brain, and from the closest section we can see actually axons of a neuron don't actually connected with the dendrites of another neuron. So the connection between themselves is called synapses. Now let's talk about activation functions. So in our artificial neural network, we have our input values and we have our output values. Output values could be anything. It could be continuous like price. It could be binary like whether a person live in the bank or stay in the bank, or it could be categorical variable. And one thing you have to remember is that all of this is a single observations. So here in the synapses between input layer and our neuron, we have weights. Weights are how neural network learns. By adjusting the weights, the neural network decides in every single case what signal is poor or not important to certain neurons and what signal gets passed along and what signal doesn't get passed along, or to what strength or to what extent signals get passed along. Weights are crucial because they are the thing that get adjusted through the process of learning. When you're training your artificial neural network, you are basically adjusting the weights in all of the synapses across the whole neural network, and that's where gradient descent and backpropagation comes into play. So in the first step, we will multiply the weights with our input value and add them up. So it's very simple. Then in the second step, we will apply an activation functions in that weighted sum. And in the third step, it decides whether it passes this signal to the next neuron or not. We will talk about some most popular activation functions. This is sigmoid activation functions, and here you can see the formula over here, and it always gives the probability of an event is happening. When you need to predict probabilities, we will use sigmoid activation functions because it will give the probability between 0 and 1 always. There is another popular activation function here, that is rectifier linear unit activation function. In artificial neural network, sometimes neuron need to fire up. If a neuron get a signal and then it realize that it need to fire up, then it will use rectifier linear unit to fire up the signal. So we use that in our hidden layers. Another activation function is hyperbolic tangent or 10-inch activation functions, and it is also used sometimes because its range is from -1 to 1. And we also have threshold activation functions which will give you yes or no answer. So let's see how and when we will use activation functions in our artificial neural network. First, we will give the weighted sum to our hidden layer. Then we will apply rectifier linear unit activation functions in the hidden layer. After applying rectifier linear unit functions, then our hidden layer's neuron will decide whether this weighted sum is important to the next layer. After that, it fires up the signal to the output layer. And here we will use sigmoid activation functions to get the probabilities of an event occurring. So now let's talk about gradient descent. If we give weighted sum value to our neuron and then we apply activation functions, then we will get an output value and we will call it y hat. But in supervised learning, we also know the actual values. So then we will calculate our cost function. So this is the formula to calculate the cost function, that is C is equal to half into the difference between output value and the actual value, and we square that value. So this is our cost function. So if we plot y hat in x-axis and this cost function in y-axis, and we calculate all the cost function for all the y hat values, then it will look something like this. And here the cost is lowest, so this is the best. And we always try to get there as quickly as possible. So how we go there? Let's draw a line instead of that. Now let's say we started with a cost over here. Then if we apply gradient descent algorithm, then it will go here, here, and here. Then it will reaches to the minimum cost. So now our model reaches in the minimum cost function. So this is the path our cost function followed when we apply gradient descent algorithm. Now let's talk about stochastic gradient descent algorithm, and it's the advanced part of gradient descent algorithm. Now let's say you don't have parabolic line like previous. Now you have these lines over here, and if you apply gradient descent algorithm, then maybe you will finish up over here. But if you apply stochastic gradient descent, then you will get the global minimum. And finally, let's talk about backpropagation. And this is actually the thing how our neural network learns. First, we give the weighted sum value to our hidden layer. Then we apply rectifier linear unit, fire them up, and then we pass it to the output layer. And in output layer, we applied sigmoid activation functions. So these all are forward propagations. Now we calculate our cost function and then we backpropagate that cost into our hidden layer to input layer. And by doing this, our neural network adjusts the weight based on the error they made. Weights are the only thing the artificial neural network can adjust in the learning process. So that's how neural network works in a nutshell.